Alrighty guys, let's start with our new chapter. So we are going to be talking about exponents and exponential functions. And I know there looks like there's a lot of boxes here, a lot of things we're going to do, but I actually cut some stuff out and I smushed some stuff together. So the first new topic that we're going to talk about are multiplication and exponents. And we're going to do this on pages 84 and 85. Although I'll probably do two separate videos, which does mean we're kind of skipping page 83 for right now. We'll come back to this one in a separate video. Okay, so if you turn the page to 84, there's nothing on it right now. We're going to start on 85. And as long as you are following along with our Desmos in class today, this shouldn't be a big surprise to you as to why this happens. But if I am multiplying exponents with the same base, so base is the big number, then my shortcut is that I can really just add up the exponents and I keep the base the same. So the way that I like to look at this one here, let me get some color. Here's my yellow one. So 4 and 3 are not the same base, but they also don't have exponents. So like straight up, I'm just multiplying those two things. Gosh, so I kind of wish I had different colors here. Like this number and that number are just big numbers. So I'm just going to multiply them because that's what we're doing. We have two numbers smashed together. So that's 12. But then what else is being multiplied is this a to the third and a to the second. And so since they're both a's, I would have a to the 3 plus 2 power, which is 5. And then lastly, I have the b's that have this same base. And so we'll have b. Now, b here does have an exponent. It's 1. So b to the 1 plus 5 power, which really then just means I can rewrite this as 12, a to the 5th, b to the 6th. Okay, so on the inside of this, we can do a whole bunch of those. Basically, if I have the same base big number, I keep the base the same and I add up the exponents. So really this has an exponent of 1. So this is y to the 6th. Because the big base numbers are the same, it's going to be m, and I add up the exponents to the 9th. Now here's where we're getting a little bit trickier. So I have a base of r, no r. And so as far as the r's go, there's 1 here, 1 there for 2. And then I have a whole bunch of n's. So n to the first, n to the third, n to the second is all going to simplify to n to the 1, 2, 3, 4, 5, 6 power. Okay, so just add them up if we're being multiplied. Now, it can get a little tricky when you have base numbers that are not the same, because then I have to differentiate the two. Like these two base numbers here, -4 and -5, are not the same, and they don't have exponents. So I'm just going to multiply them. I'm not going to add them. We're multiplying. So that's 20. But then my x's are the same base number. And so we'll have x to the 3 plus 7, so 10. And then last but not least, again, I have base numbers that are different without exponents. So I'm just going to multiply -3 times 2 for -6. Then I do have some base numbers that are the same. So I have j to the second and j to the first for j to the third, because 2 here, 1 there. And then I have k to the fourth and k to the sixth. So 4 plus 6 is 10, so k to the 10th. Super simple. Now, we can get a little bit trickier if I have a power to another power. So if I have parentheses, I really just want to think of it almost like distributive property, like you're going to multiply those. So I always think distribute. And that's because if I have multiples like down here. So, but I just multiply the 2. So b to the 15th. So if we go try a whole bunch of those, we'll have y to the 10th. Oh, now this one, the 5 is just going to the 2, so that'll be x to the 10th, x to the 3rd. And now I'm multiplying, and when I multiply, I add. So x to the 13th. Okay? Now here's where we can start distributing. Because this number outside does need to go to each exponent inside, there's a 4 on the b. A really has a 1. And negative 3 really has a 1. So it needs to distribute to all of those. And when I distribute, I multiply. So we're going to have negative 3 to the 3rd, a to the 3rd, and b to the 12th. And then the only other thing I might do is negative 3 to the 3rd, because that's really like negative 3 times negative 3 times negative 3, which will be negative overall. And then 9 times 3 is 27. A to the 3rd, b to the 12th. Okay. Now this one's got a lot going on with it because I need to distribute the 2 to each exponent in here, and every number has an exponent. Even the 4 that I don't see has an exponent of 1. So we're going to distribute and multiply the 2 here, and we'll have 4 to the 2nd, a to the 4th, because 2 times 2 is 4. But the b with parentheses doesn't have an exponent on the outside, so it's just going to drop down. Now, I don't have any base numbers the same, but I can do 4 squared, and that's just 16. And there you go. Okay, so we kind of already previewed here this power of a product. So if I'm multiplying things, then I do need to like distribute that exponent to all the exponents. And when I distribute, I multiply. So distribute equals multiply. So this 3 would get multiplied to b's exponent of 5 and to a's exponent of 2 and to 3's exponent of 1, because everybody has an exponent, even if you don't see it. When you don't see it, it's just 1. So we'll have 3 to the 3rd, a to the 6th, b to the 15th, and then the only other thing I can do is 3 to the 3rd, which is 3 times 3 times 3, which is 27. So a to the 6th, b to the 15th. Okay, and then just a bunch more in here to try. Okay, ooh, lots of distributives. So this guy here is getting a 3 to each one. So negative 4 to the 3rd, x to the 3rd, y to the 3rd, because each of them has an exponent of 1, and 1 times 3 is just 3. Now here the 3 will go to x's exponent of 2 and negative 2's exponent of 1. And these are both being multiplied because they're smashed together. So negative 2 to the 3rd and x to the 6th, because when I distribute, I multiply. Now, these base numbers, the negative 4 and negative 2, are not the same. So I can't add up their exponents, but I can do negative 4 to the 3rd, and that's negative 4 times negative 4 for 16, and then times another negative 4 for negative 64, and then x to the 3rd, y to the 3rd. Now over here I can do negative 2 to the 3rd, so negative 2 times negative 2 is 4, times negative 2 is negative 8, and then x to the 6th. And then lastly, I can now finally multiply these two numbers together. So the negative 64 and negative 8 is going to be real big, but definitely positive. So, but I'm going to get my calculator for 64 times 8. 512. But then I also notice I do have some base letters that are the same, like X here and X there, and they're being multiplied. And so when I multiply, I add, and so this is going to be X to the 9th, but then there's only one Y, so Y to the 3rd stays the same. Oof. So once we start adding in multiple things, it can get real tricky. We want to take our time. Okay, so -3, he's just chilling. There's no parentheses, just chilling. But the 4 needs to be distributed to both of these exponents in here, and both of those exponents are 1. So 2 to the 4th, x to the 4th. And then when I look at this next set of parentheses, it has a 2 behind it, so that needs to get distributed to each of these exponents. And 4 and y both have one exponent of 1. So now I'm going to have 4 to the 2nd, x to the 10th, and y to the 2nd. And then as far as all my base numbers go, all the base numbers are different. So I can't add up their exponents, but I can do the exponents and then multiply the numbers. So -3 is just -3, but then 2 to the 4th is 2 times 2 times 2 times 2, which is 16. And then I have x to the 4th. And then 4 squared is 16. X to the 10th, y to the 2nd. Okay, so now I can multiply all my numbers. The -3 times the 16 times the 16. And 16 times 16 is pretty big. I think that's 256. And then I have to times it. So 16 times 16, yeah, 256. Then I have to multiply that by -3. So, -768. And then as far as my letters go, I do have base x's that are the same. And because we're multiplying now, like the parentheses went away, we're not distributing anymore, we're multiplying these. And when I multiply, I add. So x to the 14th, and then y to the 2nd is just chilling. Okay. On to the next. Whenever I see parentheses, I think distribute, and I do have a 2 to distribute to each exponent of 1. So 2 to the 2nd, x to the 2nd, y to the 2nd. Then I have another set of parentheses, but there is no exponent outside, so that's just coming down, all being multiplied. And this one also doesn't have an exponent behind it, so it's just coming down, being multiplied. So then when I look at my base numbers, I have 2, -3, and 4, and those base numbers are all different. So I can't add up their exponents, but I can multiply them. So 2 squared is 4, and then bring everything else down, because -3 doesn't have an exponent, and 4 doesn't have an exponent. But now I can multiply these up. So like 4 times 4 is 16, times -3. What is that, 48? -48. And then as far as my base letters go, I have a base of x here and a base of x here. And because I'm multiplying, I add. So x to the 4th. And then I also have base y's that are the same. So y to the 2nd and y to the 4th. And when I multiply, I add. So y to the 6th. Last but not least, when I see parentheses, I think distribute, and I do have an exponent to distribute to all the exponents on the inside. So I'll have -3 to the 2nd, j to the 4th, k to the 6th. And then this set of parentheses also has an exponent, so I'll distribute that in. So times 2 to the 3rd, j to the 6th, k to the 3rd. So as far as my numbers go, my base numbers are not the same. So I just need to do the exponent and then multiply them. So negative 3 squared is 9, and 2 to the third is 8. So sometimes I just like to finish all this stuff first. And then 9 times 8 is 72. Then as far as my letters go, I have a J base here and here. And when I'm multiplying, I add. And so that will be J to the 10th, because 4 here, 6 there. And then lastly, I have a K base of 6, or a K with an exponent of 6, and a K with an exponent of 3. And because I'm multiplying, I add. And so 9 Ks. All right, I'm going to leave this video at that, and we will do some more multiplication properties in the next one.